Welcome to the modern mega factory, where raw elements transform into clean energy powerhouses. Solar panels are engineering marvels, capturing sunlight to power millions of homes worldwide. Inside this vast facility, extreme automation and spotless cleanrooms ensure high precision. Thousands of panels move seamlessly across miles of robotic conveyor belts every single day. The entire process begins with high-purity quartz sand, rich in essential silicon atoms. Workers inspect raw quartz rock batches for impurities before heat processing starts. The quartz is melted in giant arc furnaces at temperatures exceeding 2,000 degrees. Chemical purification converts crude silicon into hyper-pure electronic-grade polysilicon chunks. Quality control labs analyze sample purity to guarantee optimal electrical efficiency. Purified silicon chunks are loaded into heavy quartz crucibles inside specialized furnaces. The furnace slowly melts the silicon, preparing it for controlled directional solidification. A tiny seed crystal is lowered into the liquid, slowly pulling a massive silicon ingot. Once cooled, heavy overhead cranes lift giant cylindrical ingots from the growth chamber. Precision saws squarify the rounded ingots into rectangular blocks with perfect edges. Squarified blocks are inspected for structural flaws using advanced ultrasonic scanners. High-speed diamond wire saws slice blocks into paper-thin wafers, thinner than a strand of hair. Ultra-thin wafers are gently washed in chemical baths to remove slicing residue and dust. Microscopic texturing is etched onto wafer surfaces to maximize incoming sunlight absorption. Wafers enter high-temperature diffusion furnaces where phosphorus gas creates electrical p-n junctions. A dark blue anti-reflective coating is applied, giving the solar cells their signature look. Precision screen printers press ultra-fine silver grid lines onto cell surfaces for current flow. Cells pass through high-heat sintering ovens to bake metal contacts permanently onto silicon. Automated sorters test individual cell efficiency and categorize them by power output. High-speed soldering robots string cells together using thin copper ribbon conductors. Robotic grippers align multiple matrix strings on tempered glass coated with protective polymer sheets. Optical cameras inspect string alignment and check for hidden microcracks before lamination. The layered sandwich enters thermal vacuum laminators to melt protective EVA film solid. Lamination seals cells against moisture, air, and decades of harsh environmental weather. Trimming arms shear excess encapsulate foil neatly away from cured glass panel edges. Automatic corner machines press sturdy anodized aluminum frames around the laminated glass. Weatherproof junction boxes with copper cables are permanently glued and sealed on backsheets. Sun simulators blast high-intensity artificial light onto finished panels to test electrical power. Electroluminescence cameras shoot infrared images to expose invisible microcracks or wiring faults. High-voltage insulation tests verify total safety against electric shock and power surges. Robots attach protective corner guards and print serial numbers onto completed panels. Automated packing arms stack finished panels carefully into heavy-duty corrugated transport crates. Crates are tightly plastic wrapped and moved to climate-controlled warehouse distribution bays. Forklifts load pallets onto cargo trucks headed for ocean shipping ports and solar parks. These advanced panels will convert clean sunlight into renewable electricity for decades. Thank you for watching. Subscribe for more factory documentaries every week.